One of the most important and also one of the most difficult things for air conditioning and refrigeration technicians to understand is what a start relay is and how the different types of start relays work. It may not seem important when you're just looking at compressors and you're throwing gauges on systems, but the idea of the start relay can cause a lot of problems inside an air conditioning system. And it can cause a technician a lot of problems if not wired or installed properly. So that's why we want to take some time and go through this. So the purpose of the start relay is to remove the start winding or the start capacitor from the circuit once the motor is running. Compressor start relays are mounted outside the motor. You can't mount this stuff inside a motor. A centrifugal switch could not be used in a hermetic motor. There are three types of common start relays. The horsepower of the motor will determine what type will be used. The service technician may not redesign. You're not there to be an engineer to redesign what's on a system, but you do have to know why it was designed and how the different types work. There are three types of start relays. You have a current coil, you have a solid state relay that's also known as a PTC relay for positive temperature coefficient, and you have a potential relay. The current coil relay works off amperage to the run winding. On compressor startup, the motor draws a high current. It induces a strong magnetic field in the relay's magnetic coil through the run winding. This magnetic field lifts a plunger with contacts and a counter tension spring. Contacts to the start winding are made and the start winding is energized. So let's take a look at a picture of this. Okay, this is a current coil relay. We have a small spring there. Okay, we have a solenoid coil. The solenoid coil has probably some of the largest coil wire you'll see on any start relay on any coil out there. You have pin connectors. This connects into the compressor. And then you also have a stationary contact and the bridging contact. That's what moves. The way this is wired, okay, is you have your compressor terminal box. Okay, L1 comes into common. You always have one of the lines coming into common. Could be L1, L2. It's alternating current. It really doesn't matter. Okay, we have L2 that's connected to both the start capacitor and the run winding. Now the run winding is connected through the coil. So this is the one case where the coil of the relay is actually in series with the run winding of the compressor. This coil does not reduce voltage. It has a very, very low voltage drop. However, it's large. So it reacts to the amperage more than the voltage. That's why this is called a current coil. And that's why that wire on these are so large on the coil. As that coil is magnetized based on the current, it forces this plunger up to make contact. Once the current drops, that reopens and takes out the start winding, and then all we have is power to that run winding in common. Okay, so we have a winding there. This is what one of these looks like. There's a couple different configurations, but look at that size of that coil wiring. Okay, this one plugs directly onto the compressor. This one is wired in. Now, the motor now starts because of the start winding creates a strong magnetic field. Once the motor reaches about 75% of its run capacity, the current coil drops down. The relay coil is in series with the run winding. It doesn't have enough current to keep the coil magnetized. The spring pushes the plunger down and the start winding is de-energized. It's used mainly on fractional horsepower motors, okay, compressors for small refrigeration units. And it's not used that often in air conditioning. You may see it on some window units, but for split systems, for residents, and for light commercial and commercial, you will not see this used. Now, The other thing we have to note is that this is gravity sensitive. You can only install it in a specific position. Okay, that spring in there is not strong enough to overcome gravity. So again, this is just another wiring diagram of how it connects. Notice the L2 goes through the coil, which is in series with the run winding. This capacitor in here is sometimes not there. Sometimes we just do this with a induction start, induction run. All we do is take out the start winding. So just be aware you don't always see the capacitor. The next type of relay we're going to talk about is the solid state. It also works off of current. It has a material that changes its resistance based on temperature. It's called a positive temperature coefficient. When the temperature of the device goes up, the resistance goes up. It's wired in series with the start winding. This is not in series with the run winding, so we need to make sure we get it on the correct location. It uses voltage loads in series. So, example, the voltage drop across the relay would be 110 volts. The voltage drop across the start winding would be 10 volts. Remember the series voltage. Total voltage drop is the voltage drop of everything wired in series. So start relays have a very great range of motors they can be used for. Okay, they could be used for 1/16 to 3/4 horsepower, and they could be used from 3/4 to 2 horsepower. If a current coil relay was used, different relays would be needed based on that current. Very wide range. So I can carry one start relay, one solid state relay on my truck, and as long as I know how to wire it, I can use it across a very wide range of motors. So again, when we look at a wiring diagram of this, you notice that the start relay is wired in series, okay, with the start winding. Run winding has nothing in series with it, unlike the current coil. If I have a start capacitor, that would go in series with the solid state relay. Okay, it could go here or here, really doesn't matter. Okay, this is an example of a solid state relay wired. Here's our solid state relay. Okay, here's our overload. This is always wired to common. Okay, and then we might be using this as a junction point for like a condenser fan or something. L1, okay. If I have a start capacitor, as I pointed out, it just goes in series with the start relay. Types of solid state relays, you have a 2-wire, it's a relay only. 5-wire allows you to use a start capacitor, relay, and an overload. To test the solid state relay, ohm amount. A good relay will have a very low resistance reading when not connected to anything. Make sure you cool it down before testing. This is a 2-wire, relay only. This has a 5-wire with the start capacitor in it. Now the third type of relay we're going to talk about is the potential relay. Okay, it operates from voltage created by the start winding, known as back EMF or back electromotive force. If you take a voltmeter across a start winding, when the start winding is in the circuit, like with a PSC motor, okay, you will see that the voltage across that start winding is actually higher than the voltage on the run winding. The operation of this is simple. The contacts are normally closed and allow for full voltage to the start winding as the motor starts. Okay, this is an example of one of these. Okay, there's a lot of pins on here, but you're really only using 3 of them. Okay, and I'll go into that in a minute. The terminals that are used, you take line to your start capacitor, and then the start capacitor to terminal 1. Terminal 2 connects to the start winding, and terminal 5 connects to the common. Always. All the other terminals are just connection points. So when you look at these are always numbered. You have 5, 2, and 1. Okay, regardless of what other pins you have here, they're just connection points. They don't do anything. Okay, 1 gets connected to your start capacitor, which goes to line. 2 gets connected to your start winding. And 5 gets connected to common. Okay, line to start capacitor to terminal 1, terminal 2 to start winding, terminal 5 to common. All other terminals are blank. Sometimes they're wired this, you'll see them wired this way when they're on a system. To check the potential relay with an ohm meter, terminal 1 to terminal 2 has continuity. Okay, that's a normally closed circuit, terminal 1 to terminal 2. Terminal 1 to terminal 5 has an ohm reading, usually like 2K ohms or something like that. The same ohm reading should occur from terminal 2 to terminal 5. This is with it disconnected, you holding it in your hands in its normal state. When it's wired, this is what the wiring diagram looks like. We have a start power leg feeding the run of the compressor, goes to my start capacitor. That gets wired to terminal 1. Internally, there's a normally closed between 1 and 2. 2 goes to my start winding, and 5 goes to the common. Okay. Now, when the system is running, this is a 115 volt power supply. I should have some number, usually 175, 180 volts across my between pins 2 and 5. Between 1 and 2, I should have 115 volts. In other words, once it's running, it's open. And this is just an example of how these are wired and how the nomenclature is. Okay, this is a GE potential relay. Tells you exactly how to read these. This normally comes with the package. Okay, so again, this is just another example of how it's wired. Okay, again, pins 1 gets my power from my start capacitor or power directly from line. Pin 2 goes to my run capacitor or goes to my start winding, and pin 5 goes to common. Between pin 2 and 5, there is a coil, okay, that picks up the back EMF from the motor, from the start winding. Once that back EMF reaches a preset value, it's going to open the contacts between pins 1 and 2, taking the start winding and the start capacitor out of the circuit. So the operation of this, let's just really quickly go through it. Okay, when you first power up the compressor, okay, pin 1 to 2 is normally closed. Allows full voltage and start capacitance to go to the start winding. As the motor starts to run, it starts generating what we call back EMF. That's generated power by the start winding that actually feeds back and will eventually energize the coil, create magnetism on that coil that's between pin 2 and 5, which is in parallel with that start winding, because we wired pin 2 to the start winding and 5 to common. Once that back EMF reaches a certain level, it's going to open the contact between pin 1 and 2, which will take out the start capacitor and the start winding. So we have 3 types of coils we've talked about, 3 types of relay: solid state, we've talked about current coil, we've talked about potential relay. Couple words of advice, okay, always look for arrows and this side up, okay. The current coil is very important to get with the correct side up and mount it properly, and the potential relay as well. you have to mount it in the direction in the manual and is stamped on the side of it. If you mount it upside down, it's not going to work.